This is pin code for 6950. That means its diameter is 46 millimeters. Length 9 This is the same form as the Tesla electric car 4680 model. Model Y. This is the anode, and this is the cathode. It's very neat. The weight of this tablet is 430 grams. Smaller than tensile 18650. Instantaneous discharge current 10C, continuous 3C. And the capacity of this battery is 30Ah voltage 3.7V. Its anode is in the middle, and its anode is made of aluminum. Here I have welded a piece of pure nickel using a laser welder. And this is its negative terminal. The characteristic of this cell is that the two battery terminals are in the same direction. Then this one. Now I'm going to build a 12-volt storage system. 3S to P. 12V 60Ah. I'll go and measure the contents of each capsule. .62V. This one has been selected all voltage before assembling. Uniform everything from internal standby to voltage. Then mill it. Now I'm going to go shrink wrap it. And ensure aesthetics. So I've finished sewing it. Very beautiful. Now I'm going to go assemble fixed frame. Each battery has two frames like this. It's beautiful, isn't it? This is zinc nickel. I designed the fold for it, so that it fits into this battery bracket. I'm going to Korea now. First of all, this is the anode, and this is going to be the cathode over here. This one's going to go into a trench like this. I'm going to add another layer of this zinc to guide the current. Now I'm going to weld the cathode and the anode. It starts with the cathode. This is a 12 volts anode. This is a 12 volts 60Ah battery. 3.7 volts high-discharge battery used for storage, or as rescue automobile title. Alright. Now I'm going to install the BMS protection circuit. I've added a layer of double-sided tape over here. Then add a layer of insulation chips. And now I'm going to put a BMS on. This is a system circuit. Can use 3S or 4S for 3.7 volts battery. This is a 3 south system, so there will be a resistor missing like this. This circuit A instant discharge more than 1000 A continuous discharge below 120 A. BMS circuit uses high power MOSFETs. So starting with this black balance, we're going to fight. Here. Connect BO to negative battery, B1 voltage 3, 7V, B2 voltage 7.4V. And finally, the red wire will connect to the positive 12V terminal. Here. First I'm going to weld the black wire, that's the sound of the 0 volts battery block. Then there's string B1. Next is line B2. And finally, it's AB3 wire. It is 12 volts positive pole. After standard connection, we're going to measure the voltage. I will measure the voltage. The red needle goes to plus 12V. Black needle and cathode 10.86V. This is the leg. BO or B. 10.86. And this is the leg. Output charge and discharge P. 10.86 volts, such as normal operation circuit. Done correctly. Next I will go solder the negative load wire. Input of BMS circuit B voltage 0V. I use a WG10 wire, which is fire resistant and conducts electricity well. Next I will go to connect the two ends of the charging and discharging wires. The cathode, it's going through BMS, it's going into the leg P, like this. Here you have to use a high-power soldering iron. It's hard to weld a weld like this. There it is, it's burning red. Now make sure the weld is firmly fixed. The next one is charge and discharge wire plus 12V. That's it. I'll go see if there's electricity. there was electricity. Here I've added a sponge to prevent shock stabilizing the battery block inside. Now I've gone to glue the lid. So there you have it, a battery pack with a convenient handle. The weight of the whole box is only 3 kilograms.